Now, welcome to this chapter. This is chapter 11 of Redhat Enterprise Linux 1, which is actually Redhat version 8. And based on this chapter, it is chapter 11. It's all about analyzing and storing logs. So at this point, we need to understand how do we analyze and how do we store logs, or how does the system, especially the Linux operating system, store logs? And again, what do we mean by logs? So these are some of, what this chapter will entail. Now, we have the objectives of this chapter. Why do we, at first, why are we learning or going through this particular chapter? Or what do we need to understand when it comes to analyzing and storing logs? So we have the objectives. That means we have the end results. That means at the end of this session, what do we need to have achieved? Now, the objective is that we should be in a position to describe the basic logging architecture used by Redhat Enterprise Linux to record events. So there are several events that happen, so that are happening in Redhat Enterprise Linux or Redhat operating system, and these events needs to be captured at some point. So they are all captured as what? They are all captured as logs. So that is one, like we need to describe or understand the description of the basic logging architecture. Secondly, we should also be in a position to interpret events in relevant syslog files, and also to troubleshoot problems or review system status. And then again, we should also be in a position to find and interpret the entries or the log entries in the system journal. Why? To troubleshoot problems or review system status. And then finally, we should also be in a position to configure the system journal to preserve the record of events when a server is rebooted. And then finally, we should also be in a position to understand or maintain or how to maintain accurate time synchronization using something called the NTP, and configure the time zone to ensure correct timestamps for events recorded by the system journal and the logs. So there's a lot of things that needs to be, that we are going to cover when it comes to analyzing and storing logs as far as Redhat operating system is concerned. So it's all about events happening within the system. And these events, once they are there, they are captured and stored as what? As logs. So we have different events that are attached to messages. We have different events that are attached to security. We have different events attached to, let's say, when the computer or when the operating system is being booted up. We also have some events happening when it comes to the mails. So all these are captured as what? As log entries. So on this part, through this slide, these are some of the things that we were going to cover or what to learn. One is to describe system log architecture. Second is to review syslog files. Third is to review system journal entries. Fourth is to preserving the system journal. And then lastly, we will learn how to maintain accurate time. So maintaining accurate time is also part of what? Or is actually, it's something that also falls under analyzing, analyzing and storing logs. So these are some around five topics that we are going to cover more in depth. So, so just follow me and we will be in a position to understand. Now, let's start from the system logging because we are starting from this perspective. What is system logging, or what does system logging entails? Remember, it's coming from logs. So it's actually system attached to logs or logs related to system. So as far as operating system, Redhat operating system is concerned, then we have system logging. So we will be immersing, or we will immerse ourselves so much on the word logs, and we will be talking about logs. So when we talk about the system logging, these are processes, and the operating system kernel record a log of events that happen. These logs are used to audit the system and troubleshooting problems. So whenever you want to audit, let's say you want to perform some audit within the system or to your system, you must base that particular audit on logs, because it's actually the logs that can give you some direction, or give you direction to whatever thing you want to audit. Again, if there's a problem within your system, you can always check the logs, and it will, at most, it can actually give you the problem, or it can give you a platform that you can base it as a troubleshooting point. So if you want to troubleshoot your system, you must troubleshoot on a specific reason, or based on a specific reason. So this reason must always be resolved through what? Through logs. And then many systems record logs of events in text files, which are kept in the var log directory. These logs can be inspected using normal text utilities, such as less and tail. Now, remember, in the previous chapters, we talked about the Linux file system. And remember, when we talk about the Linux file system, we are trying to describe how files are stored within the operating system, or within the Red Hat operating system for this case. So the file system itself is made up of directories. So we usually have like the root directory at the top, and we have the branches at the bottom. So one of the branch of the root directory is actually the /var. So we have a directory called /var, which is actually a root directory. And then under that, we have a log directory. So, and then because we have a series, it's actually a text file. The log is a text file. So even the way we view it, we are required to use a different command, which is different from how you can view the contents of a directory. So here we are talking about the contents of a what? The contents of a text file. And since we have a lot of information within that particular file, we can use the less and tail in terms of inspecting, or when it comes to inspecting that particular file, because the list is so long. So you must also try and use the less and the tail. Now, and that is about what? That is the system logging. And if I can just show you how this works, because remember, all logs, all system logs are recorded in /var /log. I know in /var we have so many files, but we are attaching ourselves to only one file, which is actually the log. So under var we have log, and under log, that is where all the logs, all the system logs are recorded. So we're talking about the logs of events, we're talking about the events, we're talking about the entries. So all of them are recorded under /var /log. Now, so if I can take you further, we can talk about this particular paragraph, that a standard logging system based on the Syslog Protocol. A standard logging system based on the Syslog Protocol is built into Red Hat Enterprise Linux. Many programs use this system to record events and organize them into log files. So you see, with the capability of, with the capability of Red Hat Enterprise Linux, we have what? We have a certain protocol, is called the Syslog Protocol. And this protocol is meant to give proper mandate to the capturing or to the recording of all log events, or all events happening within the operating system. So there's a what? There's an authority now for the Red Hat, or there's an authority now for the events to be recorded, since we have this particular protocol attached to Red Hat Enterprise Linux. Now, the system D journal D and rsyslog services handle the syslog messages in Red Hat Enterprise Linux 8. So if given a question that what actually, or what are the services that handles the syslog messages in RHCL 8, then you can talk about the system D, journal D, and rsyslog. So we will actually see what is system D, journal D, and again, what is rsyslog, and the practicality to it. Now, come to the system D, journal D. So when it comes to the system D, journal D, remember it's a diamond. That's why we have the D, or the letter D coming at the end. The system D, the journal D. So the system D, journal D is a service. And this service is actually at the heart of the operating system event logging architecture. Remember, we have the protocol, which is the Syslog Protocol. So the Syslog Protocol allows us now to, or allows the system now to capture what? Log of events. So the system D, journal D service is at the heart of the operating system event logging architecture. Another thing about the system D, journal D is that it collects event messages from many sources, including the kernel, output from the early stages of the boot process, standard output and standard error from daemons or daemons as they start up and run, and syslog events. So it is actually the mandate of the system D, journal D to collect or to ensure that all event messages are recorded coming from different sources from the time the operating system is booted up. Remember, from that very moment, when the operating system is booted up, that is the start of the system D, journal D to collect what? To collect event messages, or to collect log entries. It then restructures them into a standard format. That is, after collecting these messages, it then reconstructs, it then restructures or reconstructs them into a standard format. You see, into a standard format, and writes them into a structured indexed system journal. By default, this journal is stored on a file system that does not persist across reboots. So the last statement there is about what? It's about the journal. Once all these messages are recorded, first of all, they are collected, and then they are restructured, because once they are collected, the messages or the local, let's say the messages or these events are meant, or they are of different types. We have those events attached to messages. We have those events attached to security. We have those events attached to boot. So after they are all collected, then the system D, journal D comes down and restructures them into a standard format and writes them into a structured index system journal. And by default, this particular journal does not persist reboot. That means if your computer is powered off, let's say, for example, there were events that were captured initially, and then you reboot your system, it means that those messages or those events that were recorded earlier have been wiped out, or they are no longer there. So it's actually the new what? The new events that are still, that are being captured now. So what happens is, when it comes to system D, journal D, it's actually a service. And this service is actually at the heart of the operating system event logging architecture. It actually plays a bigger role when it comes to collecting that. Now, that is about the system D, journal D. Now come to the rsyslog. rsyslog service reads syslog messages or messages received by system D, journal D. So you see, the service that comes first is system D, journal D. And then these messages, after they are recorded by system D, journal D, they are taken by who? They are actually handed over to the rsyslog. So the rsyslog service reads syslog messages received by system D, journal D from the journal as they do what? As they arrive. So it means that rsyslog must work hand in hand with the systemd journald. So systemd journald receives these events or records these events of messages and then hands it over to rsyslog. So what is the work of the rsyslog here? The rsyslog does what? It then processes, or rsyslog processes the syslog events, recording them to its log files or forwarding them to other services according to its own configuration. So there'll be the issue of processing and the issues of sorting. Now, the rsyslog service sorts and writes syslog messages to the log files that do persist across reboots in /var/log. In /var/log. So we will actually see how are the files, or how do these files appear in /var/log. So the rsyslog service sorts and writes syslog messages to the log files that do persist across reboots in /var/log. Now, the rsyslog service sorts the log messages to specific log files based on the type of program that sent each message or facility and the priority of each syslog message. So the work of the systemd journald is just to collect the log of events. And then it's actually the work of the rsyslog to capture those events from the systemd journald and then sorts them out by processing, by writing them in where? In /var/log. Now, the rsyslog service again, or the /var/log directory contains log files from other services on the system. So we are talking about one thing here. We need to understand the systemd journald. We need to understand the work of the rsyslog, and then the main configuration file, which is /var/log. Now, inside /var/log. Remember, we are talking about the log file. We are not interested with the var. It's only that through the var, we are able to get into what? Into log. So the following table lists some useful, it lists some useful what? Some useful files in the /var/log directory. So when you open that particular file, which you will be in a position to view it, is that we have around 5. We have, for example, /var/log messages. That is 1. So it means that in this particular file, the log entries are able to be stored by the rsyslog, or are able to be sorted and written by rsyslog into the /var/log, which is actually a configuration file in form of what? In form of messages, in form of security or secure, in form of maillogs, cron, that is the jobs, and the boot.log. So what do we mean by those log entries or those events that are captured and stored under messages? You see, most syslog messages are logged here. Exceptions include messages related to authentication and email processing, scheduled job execution, and those which are purely debugging related. So apart from this, then any other message that does not fall under this particular category, they are all stored under messages. Then we have secure. These are syslog messages related to security and authentication events. So whenever you have, let's say, the password, authentication events, or password related information, then they are all captured under the /var/log secure. So in terms of security, any security or any file related to the security of the system, and they are captured as events, they should be stored under the secure. The maillog, these are syslog messages related to the mail server. Cron, these are syslog messages related to scheduled job execution. So we have some jobs. We have jobs running in the background. We have those that runs in the foreground. So they are all taken under cron. And then we have the boot.log. So this one is a non-Syslog console messages related to system startup. So whenever your system is being started up or is being powered on, then there are logs that are captured at some point by the systemd Journalctl. So they are all captured and stored under what? Boot.log by what? By rsyslogd. So we start with the systemd Journalctl and then shifted to rsyslogd. And then rsyslogd is now connected to the configuration file, which is /var/log. Now, reviewing syslog files. Reviewing syslog files. Now, what do you mean by reviewing syslog files? Now, when it comes to reviewing syslog files, at this point, we need now to review or reviewing reviewing syslog files involves interpreting events in syslog files. And why are we interpreting? Just to help in troubleshooting problems or in identifying problems that can be troubleshooted. So, and also review the system status. So we have a lot of events here. And for this case, if I can just take you back to the operating system. This is the operating system. I want to show you that particular file. So Redhat. Now this is Redhat 8, you can see. And then let me just open the terminal so that we can see what is happening. Now this is the terminal. Now, as far as this is the terminal, we need to cd or change the directory to the /var/log. We need to see what is happening. So if I go back to, let's say, var, okay, var, cd var. So I have actually done what? I have actually connected to what? To this particular directory. So my current working directory is /var. Now, if I want to check the contents of var, I will just use ls, press enter, and you can see that we have a lot of files. Both the directories and text files are here, but we are interested with only one file, which is actually what? Log. So if you cd log, you see, for example, if you have log, so here we are given some int. And when it comes to this int, if you put LO and press enter, you'll be given a lot of, a lot of directories or a lot of information or text files or files that starts with LO. So if I press enter to this, you can now see that I am shifted or I am now operating from the log. Now, if I check the point of working directory or my current working directory by using pwd, you can see now that we have what? var/log. So this is an area where we are interested in. Now, so if I can just clear the screen and just say pwd, you can see that we are at /var/log. So what happens is, if I want to check the contents now of the log directory, I will just use ls and press enter. And you can see that we have a lot of info. Now, based on the files or based on how the log events or the log entries are stored, they are stored in mails, they are stored as messages, they are stored as security. And you can see, for example, we talked about the boot.log. That is a configuration file related to what? Related to all log entries or all boot log entries. You come to cron, we have this for cron. We have this for messages. We have this for mail. We have this for secure. And we also have a lot like spooler. Now let's see, for example, what do we have here at secure? What does secure entails? Now, at this point, this one is a text file because if I decide now to, let's say, let me just do ls. If I decide to say cd and then secure, you see it's not even accepting the cd. Why? Because it's not a directory, it is a text file. So if I do cat and then secure, you can see that it's acceptable now. It's acceptable. So if I press enter, you can see that it is done on. We are being given a warning that permission denied. Why? So when you're given like permission denied, it means that you are operating or you are trying to run a file as a regular user, while this file is required to be executed only by a super user or a root user. So how do we go about that? So if I want to go about that, I will first of all switch the account. So just say SU and then press enter, put a password, and now you are under or operating in the root user's account. So if I put ls, I'm still getting the same concept. I'm still getting the same concept. So we need to check the contents of secure. So I'll just say cat and then put secure. So you can see that we have a lot of info here. And if I can reduce my font, let me reduce my font so that you can see what is happening to 15. You can see that we have a lot of information. So there are a lot of, all these are events or local events attached to what? Attached to security of your machine or your system or the operating system. So all the authentication related events or security authentication events are captured here. Now, so if I can go back to this other part. So which other? Let's say cat messages. So you see for messages means that we have a lot of what? Log entries. We have a lot of log entries related to messages. So we may not actually interpret this, but they are very important, especially when you want to review your operating system, especially when you want to troubleshoot your operating system. You will be guided by what? You will be guided by all these events. If I can go back to cat, let's say cron, you see, all these are attached to what? They are log entries attached to jobs or relation to jobs. So this is how it is viewed. So we have this particular configuration file, which is /var/log. So it is actually the work of the rsyslog now to ensure that all the log of events captured or all the events or the log entries captured by the systemd journalctl are sorted and written down under this particular file, which is /var/log. And it is actually the rsyslog that will sort out. It will actually look at an event and say, this log entry is meant or is attached to security of the system. So where do I need to sort it out? So I need to place it under the /var/log/secure. This message or this log entry is attached to mails. Where do I need to put? I need to sort it out and write it down to /var/log and maillog. If it's a job, it will go to cron. If it's about the boot process, then it will go to boot.log. So that is how rsyslog thinks, and that is how rsyslog also sorts and writes them out. But rsyslog does not capture or collect the events. It's actually the work of the systemd journalctl to do that. Yeah. So that is about that. So when it comes to reviewing syslogs, we have that. And so when it comes to, again, another concept, which is about the log file rotation. And talking about probably going back to reviewing syslog files. You see, when we talk about reviewing syslog files, we can also talk about logging events to the system. That is like, how do logs, you see, how do events captured and how do events come? You see, it's actually the work of the system regional. So when it comes to logging events to the system, you see, like we have many programs, and many programs are attached to what? They are attached to the Syslog protocol. They are attached to the Syslog protocol to log events to the system. So the Syslog protocol is behind the logging of events to the system. Each log message is categorized by a facility or the type of message. We have this term called the facility or the type of message. And again, a priority, which is actually the severity of the message. Now, available facilities are also documented. You see, when we have different facilities within the system, they are also documented in a configuration file, which is called rsyslogd.conf. rsyslogd.conf. Let me see, rsyslogd.conf. So here it means that, I don't know whether it is, let's see, rsyslogd.conf. So I think we will come into that. We'll come into that. So let me first explain how this is. So when it comes to logging of events, you'll find that we have like a list of Syslog priorities. We have like a list of Syslog priorities. And with these priorities, it denotes something. For example, we have a code that is 0. When you see a code such as 0, as far as Syslog messages or Syslog protocol events are concerned, 0 is attached to what? It's actually an emergency. So the priority is what? Emerge. That means we have what? We have an emergency. So 0 is the code, which is attached to a priority called emerge or emergency, because it's actually a short word. And then it is again attached to the severity. It's again attached to the severity. So the severity is what? System, let's say system is unusable. So when you view, it's like the status. It's trying to give you the status of what? The status of the Syslog. So when the Syslog priority is 0, or when the Syslog priority is emerge, that means its code is 0. And what does it mean? The severity is that the system is unusable. So this actually tells you the extent on how you can troubleshoot your system, or how you can review your system based on a what? Based on a log of events or an event. Now, we have another one, like 1. 1 is a code, and it is attached to which priority? Alert. So when you view or when you see an alert, it means what? It means that the severity is that action must be taken immediately. Must be taken immediately. So coming from the word alert. So that is the priority. Another priority in this case is what? Is crit. You see, is crit. Now crit is connected to number 2 or code 2. And what do you mean by crit? Crit means what? It means that your system is actually at critical what? Critical condition. So you see, it can also give you a guidance that you are required to troubleshoot your system. You're required to do this to your system. As long as it's giving you crit, then your system is actually on a critical condition. We also have number 4, which is connected to warning. So for warning means what? It is actually warning you. There's a warning condition. Then we also have number 5. So that is the code, but the priority is what? Notice. So notice means what? It is normal. The operating system is normal, but it's a significant event, you see? So we are talking from not even the operating system, but we're talking from the event, that the event is trying to notify you about something. So it is actually a normal thing that usually happens. And it's actually a very important one, event, because it's trying to notify you about something. We also have number 6, which is about info. So for the info, this one is an informational event. So it's trying to give you some information about the system or about the event. So you're being informed of something. And then the last one, that is number 7, we have the debug. So debug is a priority, and it means what? The severity means what? The debugging level is a debugging level message. So you are required to check that particular message. So based on the priorities, you are in a position to troubleshoot your system, because if your system is in critical condition, then you have to read that event. If it's actually about the message, you have to read that event. If it's a warning, you have to read that event. If it's a notice, information, or info, then debug, you have to go by the events and by the priority, because that actually tells you a lot. So the rsyslog service uses the facility and priority of log messages to determine how to handle them. So this is configured by rules in the etc rsyslog. So let's see the rules, because already we have cat etc, then rsyslog, rsyslog.conf. This one is a configuration file. So this is where the rules are, or the rules are actually laid out. So if I press enter, you can now see that we have the rules here. We have the rules here. And if I scroll it up, you can see that we have, for example, a merge. You can see, for example, so this tells you how it is. So this is where the rules are. So it's actually a very wide file, or I can just open it in a different way. It's just vi etc rsyslog.conf. So here we can just scroll them down up to where we have the rules. So you see here we have the rules. So log all kernel messages to the console, logging merge. So we have what? We have this. One, we have all messages are recorded to where? So here it means what? Don't log private authentication messages. So info, mail, none, auth priv, none, cron, all of them are not going to be stored under messages, because if it's about authentication, it will be stored under where? Secure. Now here the authentication, or auth for authentication, priv for privileges. So the authentication privilege file has restricted access. So here we also have what? We have all these priorities. So this is an area where you can play by the rules. Then, for example, we have the /var log boot.log. So save boot messages also to boot.log. So this is what? This is about like reviewing syslog files by using the rsyslog or rsyslog.conf. And again, you can have all those files like rsyslog.conf is actually within the etc. So you must also understand the Linux file system so that you can be in a position to maneuver through all that. So under that particular file, rsyslog.conf, you will be in a position to view the rules. Now, then come this other part, log file rotation. Log file rotation. The log file rotation. Now, what is log file, or what is log rotate? The log rotate tool rotates log files to keep them from taking up too much space in the file system containing the /var/log directory. When a log file is rotated, it is renamed with an extension indicating the date it was rotated. For example, the old /var log messages file may become /var log messages -2019-0130 if it is rotated on 2019-0130. Once the old log file is rotated, a new log file is created and the service that writes to it is notified. So the importance of log rotation, you see, for example, once systemd journalctl service collects all log events, you see, these log events are being then the log events are received by the rsyslog for sorting and writing them down into the configuration files like messages, security, mails, boot. You see, they are there to be stored, but it needs to be stored for a specific period. Then after that, they are done what? They are rotated, because you see, they are rotated for the new ones to come in order to be recorded. Maximally, you'll find that it's around 4 days that these log events are captured in the configuration files. So whenever they are rotated, it means that the file, first of all, is going to be renamed with an extension and indicating what the date it was rotated. So if it is renamed with an extension, it means that they are being connected with the what? With that particular, that particular date. So if it's rotated today, then it means that it will be connected to that. So the date will act as an extension. The date will act as an extension. So initially it was /var /log /messages, but now it has been renamed with the same name, but this time around with an extension of the date. So the date, we usually know that it has an hyphen in between the year and the month, but with this, it's actually like all of them are united. I mean, they are actually grouped together, minus what? Minus the hyphens. So after a certain number of rotations, typically after 4 weeks, the oldest log file is discarded to free disk space. A scheduled job runs the log rotate program daily to see if any logs need to be rotated. Most log files are rotated weekly, but log rotates some faster or slower, or when they reach a certain size. So by default, it is always after like 4 weeks, that is like a month, around a month, that the files are rotated. So we usually have like a scheduled job. You see, you can schedule a job that after every 1 week, after every 4 weeks, after every 3 weeks, just rotate what? The log events. And the reason is to free space, to free the disk space for other log events to be captured. So it's actually giving you time, like 4 weeks. If you don't make use of those events, let's say for troubleshooting, for reviewing, then they are going to be wiped out just to allow new events to be captured. So that is about what? That is about the log events. Now, reviewing syslog files. So when you want to, let's say, for example, you want to perform that, we have a configuration command or a command that is used. And the command is what? The command is log rotate. So here I'll just do this Q, okay. Q. So we have this command log rotate. So, okay. So if you want to see, let's say man log rotate. So it gives you what? It gives you more information about this particular command. So log rotate, it means that it rotates, compresses, and mails system logs. So it must be done by what? The system administrator's manual. So you must, as administrator, you must understand this. On the description part, log rotate is designed to ease administration of systems that generate large numbers of log files. It allows automatic rotation, compression, removal, and mailing of log files. Each log file may be handled daily, weekly, monthly, or when it grows too large. And then normally, log rotate is run as a daily cron job. It will not modify a log more than one in one day, unless the criterion for that log is based on the log size and log rotate. So if you scroll it down, you can also be able to see, we have so many options to this. Yeah. So you can see here that we have these messages here. So this is a sample what? Sample log rotate configuration file. So we are giving that for messages, for all the events captured as messages or captured under message 5, they should be rotated 5, rotate 5, and then weekly, you see, and then post rotate, and then end script. So 5 means what? The number of rotation that should be done. So that is about the log rotate. But there's a lot to this. If you get more time and immerse yourself on breaking it down slowly by slowly, then you'll be in a position to understand. The important thing here is what? The important thing here for us is just to understand what is a log rotate command and how do we use it. So getting the concept in the first place is a very important aspect. So we will still do some log rotation, and then reviewing syslog files. We want to review the syslog files. So how do we review syslog files? You see, when it comes to reviewing, it's just the same as trying to see what is happening. You see, trying to see what is happening. And in this case, you'll find that by just checking, okay, for example, here it means that we talked about the services in the previous unit, and we all understand about the systemctl command. So rsyslog is a service. You can stop a service, you can stop rsyslog, you can restart rsyslog, and if you do restart, let's say rsyslog, you see it's a service. Press enter. The rsyslog is done what? It is actually started. So for you to actually use the rsyslog, you must ensure that the rsyslog is service, or as a service, is actually started. So with this particular part, you'll find that you cannot actually, the events are not actually going to be sorted and written down to those files if the rsyslog as a service is not started. So that is how you can actually work with that. So the most important concepts here for us to know is starting from the systemd journalctl, going to rsyslog, and then finally mapping them, or the events are mapped down to the configuration files or to their respective configuration files. Messages, security, boot, mail, spooler, all those. So that is how you can work with that. So when it comes to reviewing, it's all about understanding how the rsyslog works. So from the point you're moving, let's say, for example, I've actually restarted the rsyslog and I want to verify. Let's say I want to verify that all the log messages with the debug priority appears in what? In the /var. So let me create I want to appear in the /var log, and let's say messages, and then underscore debug. You see? So we do not have we have this particular file. And let me see, cat /var log messages, and then -debug. Okay, let me see up to this point. So, okay, ls. So we are looking at messages. So here you see that we have these messages. Okay. Now, the concept here is what? I want to verify all log messages with the debug priority. And I am pushing them. I want to write them down into a file that has messages and named messages -debug. So our file will be like, var /log/messages -debug. So how do we capture this? So first of all, ensure that the Syslog service is started. That means restarted. It will reboot and start again. And then secondly, I will now use a command called logger. Then -p, let's say the user. Okay, -p. We have like user.debug, user.debug, and then let me give a message. Let me call it debug message test. Yeah, press enter. So logger -p, and then user, P for priority, user.debug, and then debug message test. Now, let's see. I will just ls because already I am what? I am at log. So if I ls, I want us to confirm whether we have such a message or such a file. So in this case, first of all, let me capture something we missed. So if I come back and say tail, let's say var log, and then messages -debug. Okay, we do not have this message. Okay, it is called user. Okay, it's not actually there. So where have we gone from? So logger space -p, user.debug, and then we are trying to move it to this particular file. Just see. Okay, so first of all, okay, let me touch this file, touch messages -debug. Okay, so if we ls, I think we have this particular, yes, we have this particular file here. Now I want to log, so I'm going to use logger -p, and then put, let's say user.debug, and then I'm giving the message, let's say debug message test, debug message test. Okay, then let me just put tail /var /log /messages -debug. Okay, so okay, because it should give us something. Okay, so logger p messages. So let's see, user. Okay, so it's not coming up, but we should actually have something. So normally, I was trying to test whether we can have or capture a message that has a priority debug. And we've actually used the tail command to view the last 10 log messages from the /var log messages debug file and confirm that probably we are able to see the debug message test along other messages. Now, let me see, ls, we have messages. So let me just cut, let me have like tail messages. So So it should actually come somewhere. So we should have, okay, let me just remove messages and debug. Okay, let's see, no, cut messages and debug. Okay, so you can just remove this file, and then why? Okay, so that is, I don't know, I was trying to do some bit of configuration, I mean, trying to create a message and see whether we can capture a priority or a message whose priority is .debug, but it's not coming up. So that is about what? Reviewing syslog files. Now, there's something else now I want us to probably also talk about, reviewing system journal entries. So what do we mean by system journal entries? What do we mean by system journal entries? So when we talk about system journal entries, we are still talking about finding events. And by finding events, we are still concentrating on the systemd journal D. So systemd journal D service stores logging data in a structured indexed binary file called the journal. So we have a service which is systemd journal D. But once the data or once the logs of the log events are captured, they are actually structured and indexed in a binary format or indexed in a binary file. And the binary file is actually called what? The journal. So this data now in the journal includes extra information about the log event, you see? So it means that it's like all the events are collected by the systemd journal D, and then it stores them in a binary format while indexed in where? In a file called journal. So for example, the syslog events that includes the facility and the priority of the original messages are also captured in the journal. So what happens to this? What happens to the journal? So when it comes to the journal, how do we get connected to the journal now? How do we get connected to the journal? So how do we retrieve information from the journal? So to retrieve information from the journal, we need, or to retrieve log messages from the journal, we need a command called journalctl. So journalctl, journal for journal, and then ctl for control. These are commands. So you can use this command to view all messages in the journal or to search for specific events based on a wide range of of options and criteria. So if you run the command as root, you have full access to the journal, but regular users can also use this command, but might be restricted from seeing certain messages. That's why we have some restrictions or some limitations when it comes to privileges or rights or authority to these users. For you to have full authority or for you to have full access to any file, you must be connected as root. But for the other part, it's going to be. So now this command is called journalctl. If I press enter, what will happen? It will give me what? It will try to display or to retrieve log messages from the journal. It will tend to retrieve journal messages from the journal. If you want to stop, and the messages are so many. So if you want to stop, just press Ctrl+Z and you will stop that process. So then the journalctl again does what? It highlights important log messages. Messages that, let's say, for example, those that gives priority as notice, those that gives warning. So you'll find that especially those that gives, let's say, warning, those that gives as a notice, the priorities or their priorities are actually in bold text, while messages at the error priority or I are in red text. So let me just remove this color and see. Let me just go to preferences. This is how we readjust the colors. Let me bring our colors here. I'm changing now the color of my terminal. And then let's see, let me just press again. I don't know whether it will give us something different color. Okay, so here we're talking about probably in a different view. It will always give you all the messages or all the log messages coming from the journal. And we're talking about those that are having a priority of notice and those having a priority of warning. Their priority are always in bold text. But those that gives, let's say, messages as an error, probably they're giving it in red. So we were not in a position to view that. And yeah, so that is about what? That is about the Journalctl. But the key to successfully using the journal for troubleshooting and auditing is to limit journal searches to show only relevant output. You see, when I use the word Journalctl, it will give me irrelevant, like it will give me a lot of information, but all this information are irrelevant at some extent, because if I'm concentrating on a specific value or specific line, then it will be hard for me to find them. So the only thing for me is to concentrate to ensure that whenever I use Journalctl, it gives me what? Meaningful information. Probably I want to get the first 10 lines. Then if I do not find anything that I want in the first 10 lines, I can go to, let's say, 20 lines. So we can actually narrow them down. So if I want, let's say, the first 5 lines, I can use n. So n means number, and then say I want only the first 5 lines. So you see that I have the first 5 lines. And you can see that this is what? The priority is what? Warning, warning in bold. It's giving us warning in bold. It's giving us warning in bold. So when it comes to that, I can say, I don't want now to, and this is the important. You see, it's giving me, let me reduce this to 2. It is giving me 2 lines. If I press enter, it's not doing what? It's not giving me anything beyond that, because I've actually restricted it to only 2 lines. So that is the essence or the importance of having what? Having the Journalctl. But again, we can say, you want, let's say, add. Let me just use add Journalctl. Journalctl. Let me see. Journal. Okay, so it means that head cannot be used with that, but I can use Journalctl -n or let's see, let me say less. Okay, so this one will give me in terms of some few lines, which is similar thing to the other. Now, so that is about what? That is Journalctl. It's actually a command used to review. It's actually a command used to view what? To view or to highlight important log messages. So in general, it must work hand in hand with what? With the systemd journald. So systemd journald writes log events or log messages in binary format and index them and write them in what? In a journal. Then for you to retrieve the information from the journal, for you to view the log messages from the journal, you need to use the Journalctl command. So I know there are a lot of things attached to that. And again, you can say, I want to review or I want to see the log messages that were captured either today, captured yesterday, captured tomorrow. So when looking for specific events, this is how you play around, or this is how you work out. So if you are looking for specific events, you need to limit the output to a specific time frame. You have to limit the output to a specific time frame. For example, the Journalctl command is heavily used in connection to the specific events you want. So here it means that the Journalctl command has 2 options to limit the output to a specific time range. For example, we have this. We have since, since, and until. So you must concentrate with this. The hyphens are 2. So what are you doing here? Or what do you are getting here? It means that I'm trying to look for specific events given a time frame or given a specific time frame. So both options take a time. And here we have again the arguments. So the argument can be yesterday, the argument can be today, the argument can be tomorrow. So how do we go? How do you go about? So here it is. So you can say journal, you can say Journalctl, and then hyphen since. Okay, so why? Just give 2 hyphens. Since, let's say since today. You see, these are for today. These are events that are captured what? Today. Now, if you want for yesterday, you can just change what? Okay, since today, but you can say, you can use now both sides. Since today, let's say until today. You see, until today. So the logs begin at Friday. So 2021-11 at around 0944. That is the time when I started my operating system. So until today. You can again have until tomorrow. Let's say until tomorrow. You see, until tomorrow. Of course, that is something in the future. You can say, so you can say since today, until tomorrow, until yesterday. So this is how you can do what? This is how you can look for specific events given the limit. Given the 2 limits, that is hyphen since and hyphen until. So with Journalctl, you are actually in a position to do what? You are actually in a position to work it out. But still, apart from today, tomorrow, and yesterday, you can still narrow them down. Let's say up to a specific time. You can still narrow them up to a specific time. For example, you can say Journalctl, let's say since, let's say 2021, let's say 2021, 03, let's say March, and then let's say 10th, and then what time? Let's say 10, okay, 10:30, 00, and then say until today. So what is today's date? 2021 hyphen, is it 20 what? Is it 26? Of course it is 11, then 26, and then what time? Let's say 16, 00, 00. So you see, so since, that is since March up to today. So if I press enter, it will still give me all these log entries. So you can now set yourself or fix yourself on a specific time frame. You can still fix yourself on a specific time frame. So we are talking about from March up to today, from March until today. So that is how we can capture these log entries. Okay, so coming towards the end now, I know that we've covered a lot of information, a lot of files. So when you talk about now something else to note, when storing the system journal, if you want to store the system journal permanently, because one, it has been captured in a journal, but how do you get to know the configuration files attached to these journals? So by default, journals are kept in /run. So we have /run, /log/journal. This is what? This is the default file for what? This is the default file for journal. So you see /run. So you get to the root directory called run, get to log, and then you get the journal. So these are directory, which means the journals are cleared because once they are stored here, they are usually cleared when the system reboots. So it means that no journal survives reboot. Once it's like the log events. Once they are captured in, once they are captured in the log /var/log and the messages and the secure and where, once the system is rebooted, then they are cleared. But you can change the configuration settings of the system journal service here again. So because the journals are captured here, if you want to change, you can always change here, etc systemd, and then we also have journal. We have journald.conf. This is a configuration file. Journal. Okay. So let me just cut and see. /etc /system d/journal. Yeah. So you can always, or you have the option of changing the configuration settings of the system journal service. So if you want to make or to ensure that the journal survives reboot, or the journal, the journal is maintained the way it was even after reboot, then you can change it here. So let's see how this is done. So if you press enter, you can see that we have a lot of information. And this is actually like a storage parameter. So this is like a storage parameter. And if you want to change how the journals are going to be either to survive reboot, not to survive reboot, this is where you can change that. And in this case, this storage parameter actually defines whether to store system journals in a volatile manner or persistently across reboot. So here it means that we have like 4 options. You can set to persistent, you can set to volatile, you can set to auto. You see? So we have like those options. Now, when you set this to persistent, let's see. You see the storage here. When you set storage to auto, now for the auto, it means what? Auto means what? The rsyslog determines whether to use persistent or volatile storage. It's optional. It's an automatic. But now, if you change the auto to persistent, it means that the journals will persist across reboots because you're putting it what? Persistent. It will persist across reboots. If you put to volatile, it means that it's volatile and it is temporary. So all the files are temporary and exist only in the runtime memory. So it is always advisable that if you want to ensure that the journals survive reboots, or to want to make them volatile or persistent or auto, you can always come to this configuration file, which is actually /etc /etc /systemd/journald.conf. That is a configuration file attached to that. Then coming to something else, coming towards the end now, it's about maintaining accurate time. So how do we maintain accurate time? So this is a concept, a very important concept at this point. So maintaining accurate time means what? We are talking about how do we set the local clocks and the time zones. How do we set the local clocks and the time zones? So you see, correct synchronized system time is critical for log file analysis across multiple systems. And the network time protocol, we have this particular term, network. So we have NTP, which stands for what? Network time protocol. Network time protocol. What do we mean by this, or what does it stand for? NTP, or network time protocol, is a standard way for machines to provide and obtain correct time. And to provide for what? It provides information or correct time information on the internet. So a machine may get accurate time information from public NTP services on the internet, such as the NTP pool project. A high quality hardware clock to serve accurate time to local clients is another option. So here it means that for you to get a standard way of obtaining time or correct time information on the internet, then we have a platform or a utility called NTP. Now, how do we alter this? Generally, how do we alter this? So we have a command, just the same way we had the Journalctl. We also have time date CTL. So time date CTL is a command that shows an overview of the current time related system settings. So the current time related system settings, including the current time, the time zone, and the network time protocol synchronization settings of the system. So let's see how this works. So if I press enter, you can see that we are getting all this information. So today's Friday, and then we have this particular date that we've been given in terms of the year, month, and day, and then the time. So you can see we have the local time, we have the universal time, we have the RTC time, we have the time zone, the system clock synchronized ZTS, the NTP service, is it active or inactive? The RTC in local TZ, that is unknown. So all this actually gives what? So a database of time zones is available and can be listed with probably this particular command. So if you want to see the time zones, because I know we are in different time zones. I can be in Africa, Nairobi, you be in Africa, Ethiopia, Africa, you see, we are in different time zones. So how do we list all these time zones? Assume that I do not know these time zones. How do I go? How do I go about? So, okay. So we have time date CTL. Okay. And so time date CTL list. So I'm just using this list, then hyphen time zones. So all these are what? All these are time zones. So you can be in Africa, Abidjan, Africa, Accra, Africa, Addis Ababa, Africa, Algiers, Africa, Asmara. So these are what? These are time zones. These are time zones. So you can change, you can decide to change the time zones, because by default, if I run time date CTL, you see, I am actually in Africa, Nairobi, but I have the options of all these time zones. I can change to Africa, Conakry, or Africa, Dakar, or Africa, Dar es Salaam. So with that, how do we change that? Now, with that, we have this option. So if I want to set it, let's say Africa, Cairo. I want to set it to Africa, Cairo. How do we go about that? So first thing is for you to understand or to know what the time zone. So just say time date, CTL, and then say set time zones, and then say Africa / Cairo, then press enter. So set time zone. If you come back to date, time date CTL, you can see that we've actually changed Africa Nairobi to Africa, Cairo. Africa, Nairobi, to Africa, Cairo. That is how to do what? That is how to set. Again, what is the time? So if I want to bring it back to my time zone, I can say Africa, Nairobi. So if I go back to time date CTL and press enter, you can see that we are back now to Africa, Nairobi. Now, so if I come back here and say, okay, so it is correct that Africa, Nairobi. Now, how do we set the time? Let's assume that my correct time is 15:39. How do I set to that? So you will use the same command, time date CTL, and then say set time. And then this time round, you have to say 15 full colon, let's say 40, and then you can say 00. If I press enter, failed to set time, NTP unit is active. Now, in this case, it means that if the NTP is active, that means because it's a network time protocol, it means that it will try to find automatic time on the internet. So I'm trying to go against the rule or against its rule. So if it's active, then I don't need to do what? To set the time, because it will pick automatically from the net. So how do we go about that? Because if it is active, let me just try it one more time. Set time, you can even say you want to put it, let's say 3, or change it to 3 something, press enter, you see, fail to set time, NTP unit is active. So we need to deactivate the NTP. So how do we do that? I will now use clear. So time date CTL. Now, to do that, sorry for that, I don't know why it's going down. Okay, let me just use time date CTL, and let's say set NTP. Then is it true? Let's give it false. Time date CTL set -NTP false. So if I go to time date CTL to confirm, now you can see that here NTP service was active, but here NTP service has been switched to inactive. So inactive means what? False. True means what? I mean, yeah, true means active, false means inactive. Now, when it comes back to, let's say, setting now the time, you press enter, you can see it's going through 1540. When I come back to time date CTL and press, you can see my time is reading what? 1540. So if I want to ensure that my time is picked from the internet automatically, I have to ensure that the NTP is what? Is active. So I will go back and set it to the correct time. So 42, and then let me say 14, press enter. But this time round, I want to adjust the NTP. So time date CTL set NTP. This time round, I want it to ensure that it is what? It is true. So my time will be picked automatically from the internet. So here it is active. So that is the reason, or that is how you get rid of so many things, and just let the system pick the time date or the time automatically from the internet. So with that, we've actually come a long way from discussing, like describing the system log architecture, reviewing syslog files, reviewing system journal entries, preserving the system journal, and then maintaining accurate time. So you should be in a position to at least describe something in all these topics. So With the last or to summarize this particular chapter or this particular topic is that the systemd, journalctl, and rsyslog services capture and write log messages to the appropriate files. The /var /log directory contains log files. Periodic rotation of log files prevent them from filling up the file system space, that is to free disk space. And then the systemd journals are temporary and do not persist across reboot. But if you want to persist across reboot, then you have to change it from somewhere. That is the /etc/systemd/journald.conf. And then the cron d service helps to synchronize time settings with the time source. And then lastly, the time zone of the server can be updated based on its location. So these are some of the summary of what we've talked about so far. And yeah, it is high time for you now to take the initiative and dig more on analyzing what? Analyzing logs and storing logs. So analyzing logs and storing logs. So up to there, probably I'll see you in the next chapter, which is chapter 12. So thank you